think you are strong enough to bend one of these pieces of steel? With heat and special equipment, it is possible actually to bend steel. Or what about this wooden log? How would you go about splitting it? This sharp axe easily cuts through this log. Or what about this ice? How would you go about cutting it? This powerful chainsaw is designed to cut through hard objects like ice easily. Or what about this strong piece of nylon rope? How would you go about breaking it? This high temperature flame can be used to divide the rope by actually melting it. The reason these substances are so strong and difficult to bend, break, cut, or burn has to do with the arrangement of atoms and the bonds between them. A chemical bond is an attractive force that holds atoms together. Chemical bonding is the process of atoms combining to form new substances. During the next few minutes, we are going to explore how atoms bond and the different types of bonds they form. Understanding the structure of the atom is important in understanding how chemical bonds form. This substance is limestone, a rock found in the earth. Limestone is mined in quarries like this one and is used in a wide variety of products. For example, limestone is an important component in cement used in building all types of things. The major element in limestone is calcium. This is a calcium atom. At the center of the atom is the nucleus. In the nucleus are two types of subatomic particles called protons and neutrons. The orange particles with the plus sign are the protons, and the blue particles with a neutral charge are the neutrons. The nucleus carries an overall positive charge. Orbiting the nucleus are negatively charged particles called electrons, seen here in red. The negatively charged electrons balance the charge of the positively charged nucleus. This makes the overall charge of the atom neutral. In order for the atom to maintain an overall neutral charge, the number of electrons must equal the number of protons. Here, in our calcium atom, we have 20 positively charged protons that are balanced by 20 negatively charged electrons to make the overall charge 0. Electrons hold specific positions orbiting the nucleus. We refer to the position in which electrons orbit the nucleus as an energy level. Each energy level can hold only a certain maximum number of electrons. The first or innermost energy level can hold no more than 2 electrons. The second energy level can hold as many as 8 electrons. And the third energy level can hold as many as 18 electrons. Larger elements have many more energy levels than just 3. For example, gold has 5 energy levels. Energy levels fill up with electrons, starting at the innermost energy level and work outward. The electrons in the outermost energy level are referred to as valence electrons. The valence electrons are very important in determining how an atom bonds with other atoms. Matter tends to exist in its lowest energy state. Matter in a higher energy state tends to be unstable. Matter, such as this salt, in its lower energy state tends to be more stable. If matter, or an atom, is stable, it is not likely to form bonds with other atoms. But if an atom is unstable, it will have a tendency to form a bond with another atom. Let's take hydrogen, a gas common in the atmosphere and in the air we breathe. Hydrogen has 1 electron in its energy level. But as you recall, the first energy level is capable of holding 2 electrons, and therefore hydrogen needs a second electron to become stable. It can combine with another hydrogen atom so that both atoms have their energy levels complete with 2 electrons. Valence electrons in the outermost energy level determine an atom's stability and how it will bond with other atoms. When the outermost energy level of an atom, such as neon in this sign, is full, it is very stable. Helium, another stable substance, is a gas that is lighter than air and makes this helium-filled balloon float. Helium has its outer energy level full with 2 electrons. But elements, such as copper seen here, in which the outermost energy level is not filled with electrons, are less stable and are more likely to form bonds. Let's take a look at common types of bonds: ionic bonds, covalent bonds, and metallic bonds. The first type of atomic bonds we will discuss are ionic bonds. An ionic bond is a bond in which one atom gives up one or more electrons and another atom accepts the electrons. Ionic bonds are quite common. Concrete, seen here in this sidewalk, is held together with ionic bonds. Lime, often used to change the chemistry in soil, is held together with ionic bonds. Why does ionic bonding occur? As we discussed earlier, bonding is largely influenced by valence electrons, the electrons in the outermost energy level of an atom. And those atoms tend to bond with other atoms to make their outer energy level full, and thus become more stable. In this burning piece of metal, an atom of magnesium with a small number of electrons in its outermost shell donates electrons to an atom of oxygen that needs those electrons to fill its outer shell. Here you can see an atom of magnesium with 2 electrons in its outermost energy level, and an atom of oxygen that has 6 electrons in its outermost energy level. These atoms form an ionic bond when the magnesium donated its 2 electrons to the oxygen, so that the oxygen's outer energy level became filled with 8 electrons. When the magnesium donated the electrons, it became positively charged. When the oxygen gained the electrons, it became negatively charged. Atoms with a positive or negative charge are called ions. In our example, the magnesium is written 2+. It has a positive charge because it has lost 2 electrons. The oxygen is written 2-. The oxygen has a negative charge because it gained 2 electrons, but when the magnesium and oxygen combined to form magnesium oxide, it has an overall neutral charge, with the positive and negative ions canceling each other out. Remember that atoms are held together by the attractive force created by negatively charged electrons rapidly orbiting around a positively charged nucleus. The attractive force between electrons and the nucleus can vary depending on the atom and the position of certain electrons orbiting the nucleus. In order for a valence electron to be taken from an atom by another atom, a certain amount of force needs to be applied. Ionization is the process of removing electrons from atoms to form ions. The energy needed for ionization to occur, the removal of electrons, is called ionization energy. These metal objects contain the element copper. Atoms that have a small number of valence electrons, such as copper seen here with 1 valence electron, have a low ionization energy. Plants produce the very important element oxygen that we inhale in the air when we breathe. Atoms that have more valence electrons, such as oxygen with 6 valence electrons, tend to have high ionization energies. They do not lose electrons easily. Chlorine is often used to kill bacteria, as is the case with this chlorine being placed in a swimming pool. Chlorine has 7 valence electrons and easily gains electrons when forming ionic bonds. Electron affinity is the tendency of an atom to gain electrons when forming bonds. Atoms, such as chlorine, are said to have a high electron affinity because they attract electrons easily. The grains of salt sprinkled out of this shaker are ionic compounds. Here you can see a small atom of sodium bonded to a large atom of chlorine. A grain of salt is arranged in a very regular pattern, with each sodium ion surrounded by 6 chloride ions, and 6 chloride ions surrounded by 6 sodium ions. The pattern seen here is called a crystal lattice. A crystal lattice is a three-dimensional pattern of ions that repeats itself. There are many different shapes of crystal lattices of ions. These large salt crystals have a cubic shape. This quartz crystal has a hexagonal crystal shape. Let's take 2 chlorine atoms, for example. Chlorine has 7 valence electrons. They both need 1 electron to fill their outermost energy level. It is possible they can share a pair of electrons so that both atoms have a full outer shell. This is called a covalent bond. A covalent bond is a bond in which atoms share electrons. We can show this through a diagram called an electron dot diagram. An electron dot diagram is an illustration that shows just the valence electrons of an atom. For example, the electron dot diagram for the bond formed between 2 atoms of chlorine looks like this. Another example of a covalent bond occurs between hydrogen and chlorine, where hydrogen has 1 electron and chlorine has 7 electrons in its outermost shell. You can see from the diagram that each element has filled its outermost shell, enabling the molecule to be stable. Compounds made of covalent bonds are quite common. The major nutrients in foods, such as carbohydrates, fats, proteins, and this piece of fruit, are made of covalent bonds. The metal in this spoon is able to be bent without breaking due to its bonds. The bonds allow the ions to easily change position. The third type of bonds we will consider are metallic bonds. In a metallic bond, many electrons are shared by many atoms. The positively charged nucleus is surrounded by free-moving electrons. One property common to metals with metallic bonds is malleability. Malleability refers to the ability of metals to be bent without breaking, especially under heat. We have explored the major types of bonds, including covalent, ionic, and metallic bonds, and their characteristics. Next time you think how matter is held together, remember the bonds that bind atoms together. You just might look at things a little differently. Fill in the correct word when you hear this tone. Good luck, and let's get started. Number 1. A chemical bond is an attractive that holds atoms together. Number 2. Chemical bonding is the process of atoms combining to form new. Number 3. Matter tends to exist in its energy state. Number 4. An bond is a bond in which one atom donates electrons to another atom. Number 5. When the number of protons equals the number of electrons, an atom has a charge. Number 6. Ions are atoms with a positive or negative . Number 7 is the process of removing electrons from atoms to form ions. Number 8. Electron is the tendency of an atom to gain electrons when forming bonds. Number 9. A bond in which atoms share electrons is called a bond. Number 10. In a bond, many electrons are shared by many atoms.